everyone, welcome to my channel. So today we are going to be talking about lists of lists equals to metrics. List of lists equals to metrics. Okay, so before we proceed, because I'm also going to add a few tricks on how to calculate metrics using a list in our next course after this course. So that is just a bonus to that. So I'm going to show you that right away, but not actually in this project, because after this project I'm going to do the next one still under the metrics, so you understand the list of lists we are talking about. So metrics, it's simply a topic, basically for me it's simply a topic in mathematics where we used to add two or three different rows and columns together, and we get our final output. Most times we use it to calculate the determinant or find the determinant. Sometimes we use it to calculate quadratic simultaneous equation that comes in that have two unknown or three unknown, or however. So that is the importance of metrics. There's a place where you need it to solve complex problems, not just only knowing how to solve those math, but applying it to solve real life problems. So so we want to create our own lists into another list, which is going to give us metrics. So we're asked to write a function that prints a matrix of integers. So actually we have a matrix arranged, so we want to print out all those value out. So just like that, and just like that. So so the format, say example, you're not allowed to import any models. You can assume that the list only contain integers. You are not allowed to cast integers into string. You have to use string formats to print integers, which is very important. So then we have the following stuff there which we will be using. So that is that. So whenever we run this, we get to see something. This is what we are going to do for testing it. Then whenever we run it and put cat is, this is what we are going to see at the end, just like that. So so just like this, what we have here, print main.py, then /cat-e. So we are going to test that right away and see how it works. So without wasting much time, we are going to go ahead. So I just need to make sure I was able to exhaust everything I need to exhaust before moving further. So I'm going to open my terminal. So opening my terminal, so this is what we have there, but I'm just gonna start all over so for clearer understanding. So I'm going to go to our main place, then clear all what we have here. So we are going to get started. The first thing we're going to do is we are going to go to our environment where we have been making use of. Then we list what we have there. So we are under the Python data structures. So I'm going to cd inside 0x03 for that. Then I'm going to list what we have. So this is where we stop. So we stop at 5. So we are going over to the next, we are going to the next one, which will be 6, which is list of list metrics. So what are we doing in this course actually? So the first thing is I'm going to create a file name and open it. So the name of the file is going to be 6-print then underscore metrics, trix, like that, metrics, then underscore integer. So actually is long, but that's the name we're asked to use. So I'm going to hit enter, and straight ahead is going to open where we'll start typing our code. So the first thing I'm going to be doing is I'm going to put the hash symbol, then the exclamation mark, slash. I'm going to put the USR. I'm going to put the slash BIN. Then I'm going to put the slash PYCHON3, just like that. Good. So we are good to go. We are good to go. Now that we have that set in place, what's the next thing to do? Now the next thing to do is we are going to define our function that we are going to be using it to test. So the function is print underscore metrics underscore integer. So print underscore matrix then underscore integer. So I'm gonna cover that in a bracket. So we all know that in a list we always have something like this. Let me show you what we always have on a regular list. So we always have a simple square bracket like this, which tells us that this is a list. But this time around we are dealing with what is called multi-dimensional list. That means we are going to have a list in a list. So that is why the title was list of lists is equals to metric. So we are going to be having a list in another list. So I'm going to put another box in it. So the list has another child, another children. So you can see have another child inside another child. So it's multi-dimensional list, and you can easily access all those stuff right away. So that is for the definition of the function. So now we want to access the function, but to give a clear idea, let's assume as if we have run our function. So I'm just going to copy this right away. I'm going to copy that, and I'm going to paste it here. Open. So I want to call my function. So assuming my function holds a list. So let me give you one. That's okay. This is a list. I'm trying to arrange it. I don't want it to look so scattered and complicated at the same time. So like this is okay. Or let me take it back. Okay. So like from this point, so I'm gonna hit enter to go to the next line. So now you can see in between there we have a list. a very first list, then in it we're still going to create another box inside it. So the first box is going to be holding 1, 2, 3, just like that. Now put comma, then go to the next one. I'll put my box there too. 4, 5, 6, then go to the next one. So you can see I'm creating the list. So I can put 5, sorry, I have 5, 6, 7, 8, 9. I can even add it up to 3, but that will be wrong, because in a matrix you can't have such list. It's either 3 by 3, 3 by 4. So you can't have 3 by 3 and one side is by 4. So but actually that will even work, even though you do that for the sake of this course. That should work. So I'm going to pull this away like that. Good. So this is what we have in our list. So we have the open and closing list, which is highlighted. Open and closing bracket, which is highlighted, followed by the square bracket, which is the mother list. And inside the mother list we have children list, which is 1, 2, and 3, which are the children lists we have in there. Now in it, I can go back to my function. So now, because this is where it will make a meaning of what we are really doing, so I'm going to hit enter to go to the next line. Now in here I want to loop through all this list the way they are arranged. So to do a looping, if I do a for loop, so what is the name of the list? So let me assume that that is X. Whenever we have 2 dimensions of something, we always refer them as X and Y. When it is 3 dimension, then Z comes in. So we have X in. So most programmers, they always make use of I and J. Yes, and key, IJ key. So whichever one you prefer is good. So X in, then we just call the name of the lists, because when you call the name of the list, which is matrix, automatically you have access to both the mother list and the children list. So that's right, simple. You don't need to go through adding up lengths to get the full length of, or that should be a waste of time. But this gives you full access to everything. Now if we loop through this is going to give us, let's see it ourselves. So I won't be the one saying everything here. So I'm just going to loop through X so you see what we got there. So let's list and see. We have this, so I'm going to convert that so that it can be executable. So I'm going to ch mode, then u plus x, then I'm going to put that for execution, then slash, then a 6. Now you can see how it's printed. It printed it individually. Each list was printed out, which is 1, 2, 3, 4, 5, 6, and 7, 8, 9. So those 3 points was, and this loop runs only 3 times. The first time it runs, the 1, 2, 3 was printed out. The second time it runs, the 4, 5, 6 was printed out. And the last time it runs, the 7, 8, 9 was printed out. So that's 3 times it loops. Now we want to loop through not only through that, but we want to loop through the remaining or the rest individually. So they have two ways we can do that: by putting a loop on another loop, but that should be a waste of time. Now I'll explain what I was talking about earlier. Some people might want to do something like x, then putting y in it. Oh, let me show you what I'm talking about. So I'm just gonna come to this place. So here we have for x in matrix, and I'm gonna create another for loop. So I'm gonna call it y. So in y will also fall in each value of x, because x is another list on its own which loops through all those information. So x will represent y in x, so y will represent the 1 2 3 individually. So you can see how through these 2 points we were able to access the total value of the matrix by having two x and y. So now if I come in here and print, so I want to print y like that. So let's go ahead and test that and see what we get. You can see we have 1 to 9 printed out with a new line after each word. So that means we are accessing each value in the matrix or in the multidimensional list. So now what we're asked to do, if you look at our project, we're asked to create something that looks like the previous one, but each individual number are affected. That means each individual numbers in a set was touched, right? We were able to access all the numbers, but it, instead of being arranged on one line, we want it to be arranged in group of 3 by 3 without the bracket or the square brackets on it. So that is what we want to solve. Now to do that, I don't want them to be on creating a new line individually, so I'm going to stack them on one line. So I'm just going to say print. I'm going to open that and put double quote in it. I'm going to put my curly braces. So in the curly braces I'm going to put column D for integers, then I'm going to put my format method. So I'm going to put it, then pass in the value of y, because we are able to access y. Y goes like 1 2 3 4 5 6 7, you understand, but x goes in the list 1 2 3 in a square bracket, 4 5 6 in a square bracket, and 7 8 9. So that's the difference. So now that we have done that, actually if we print this, we still get the same results. Now let me escape and let me print this. You see we still have the same results, still 1 2 3 4 5 6 7 8 9. But you know what we always use to remove new lines. So I'm going to add, going to add a comma and end. So I'm gonna put this just like that. So you can see everything now is on a straight line, but our stuff here is being affected, so I would like to bring it down. So for me to bring it down, I must make sure I'm out of the function totally. So to go out of the function, I need to go backspace, then go backspace. Then I can print an empty stuff there. So that's going to create a new line, after which my loop is done running. You know, my loop starts from this point, still the same line, you can see, and my print starts from the same ends on the same point in which the loop started from. So if everything here is if, therefore everything here will be else. So after all this is done running, then this other part will run. So you are going to experience a new line. So you can see it's a little bit neat now. Now that we have 1 2 3 to 9, then followed by a new line. So now it looks a bit neat. Now the next thing is I want it to be counting to detect the end of every children matrix before it goes to the next line. So that is what I want to do. So now that I'm able to print it, I'm going to give an if statement. So if what? If y. Okay. So if I give such condition, I must look for a way to restrict most of the stuff there, but I'm going to show you where I'm going to position that. So if y, or if y is not, so if y is not equals to the last value of x, so you know that x always prints a box, and a box, just like that. So if I access one of these box and the value of y is not equals to this, the last value here, then something should happen. So I'm just going to access the last value of each children element. So to access the last value, we don't know how many element that is going to be provided, but to always access the last, no matter the number of element provided, is to use the minus symbol. So you can say -1 to access the last element there. So you can see, so if y is not equals to the last element we have there, then I might decide that this should keep on the process of printing as far it is not equals to y. So I'm just gonna copy this, and I'm going to paste it here. just like that. So I'm going to go ahead and check that and see what our outcome is. Okay, on line 5. So I'll come over here. There's the line we have an issue, and I'm going to add an indentation there. So I can go ahead and run that. Okay, so we are having a little issue which we need to solve. So it's better I remove this from here and place it here. Take it back. So now I think I'm still going to create another print to solve that issue right away. So in it, because we are looking, because this is going to create a new line, so if it reaches there, let us just give it an end. Just like that. So let me come in and give it a good space. So that should be good. Okay. So I think I should push this to the next line because it is not breaking my code. Good. Good. So this is what I was looking for. So we have 1 2 3 4 5 6 7 8 9. So just like that. Now this is the whole concept of what is going on. So the whole concept of what is going on is very, very simple. So just permit me to open it and view to show you. So it's probably going to come up. You just need to be a little bit patient. Okay, so now this is the whole concept. That's why I told you that it runs 3 times. Oh, sorry, the x run 3 times. It runs at the first time as 1 2 3 1 2 3. I'm just repeating it, but it only runs once. Then inside it, the y runs based on the number of elements that is provided. So under x, the last index here at this place is what? 3. When we have looped through the first information and it is 1. The last info here, still on the same x, is what? Is 3. When we loop through the next information, it's what? 2. The last information here is 3. And when we loop through the information here on y is 3. So that's why we say if y is not equal to the last form of x, then something should not happen. So let me show you again, so you get that through the code, so you understand what the code means. So that's the statement we have here. If y is not equals to the last value of x, then I want you to print the value and then add a space in there, else go out of the loop and do whatever you see there. So when going out of the loop, there's a print statement here, and this print statement, what does it do? The print statement is going to break out of that loop and go to the next line. So this print statement always creates new lines when values or when informations or data are not passed to it. Even when information are passed to it, it creates new lines. So for you to get rid of those new lines is when you add your end. So now let's explain over again. I loop through the first children, which is the list themselves. Then I go further beyond what the x to a y, which is the element inside the children. Then I went further to print all the information in there. So it keeps on printing. So at the first stage, which is the box containing the 1 2 3, the box containing the 1 2 3 here, when x is box 1 2 3, y will loop the first time 1, loop the second time 2, and still keep on looping 3. Now what happens? Y loop here, meanwhile maybe the last value of x here is -3. Y is going to loop and it got the first answer, which is 1. Then it's going to come ahead and read this, and you see that it was told to print a y, so it's going to print a y. Then it will come over and check this this statement. Is y not equals to the value we have there, the last value of x? Yes, y is not equals to it. So it's going to go further and print a space to it. It's going to add a space to it. Then it won't go out of the loop. Instead, come back again to this particular loop. of y in x because its work is not finished. We just loop through x. Based on the number of elements we have in x, y will keep on looping till the number of elements in x is fulfilled. So it's going to go back to this for and check if y in x. Good. At this time around, y is no more 1, y is now 2 because it's looping to the next value. So we are going to be printing the dot format as usual, which is going to print the next number. Now when printing the next number, it will move over to check if y is not equals to x, and the next number will be what? 2, which is the 2 here. The last value of x is what? Minus is 3, so it is not equal. The condition is true, so it's going to go over and print this, what we have here, print this new line and returns back again to this point of the 4y in. So this time around is going to do the usual printing of this. Then when it gets to this point, if y is not equals to x, was this, at this time around y is equals to that last value, so this cannot run. This print statement we have here can't be run because this condition is false. Based on that ground, it is going to break out of this first loop and go back to this other loop after printing the value. Now that we have the other loop, by this time around it is no more 1 2 3, it is now 4 5 6. So the same process is going to carry over till when this gets to this point, and finally we have our printed out. Now it loops out of this function, so nothing to run again. Now the next thing is going to come to this place to run your function right away. So that is that for that. So I hope you guys enjoyed this course. So actually I've not forgotten the matrix projects, which I'm going to do right away. So please stay tuned. Make sure you subscribe, like and share, and have a nice day.